Hey nerds, we're gonna try this out with a little bit of tech today. So I'm gonna try to run through this mid-unit quiz review with you and buzz through each problem and sort of explain it. I'm gonna go kind of quick, but so you can slow me down if you like, or whatever you need to. So let's check out this first one. We're just trying to sketch this. So I know wherever this line, I don't know, this line might look like that. Wherever it hits this point, it's some distance over for x, but it's not up or down, so its y value is 0, right? The y value is 0. The x is something. In this case, it might be 2.3, but the y value is 0. So if we want to find this spot, regardless of where it is on the line, we can just plug in 0 for y, because we know wherever it is here, it won't be up or down at all. So let's try that out. This will be 4 times 0, so this whole thing cancels out, and we'll just be left with 3x equals negative 12. And when you divide by divide by positive 3, you get x is negative 4. So this should hit the y-intercept here at negative 4, right there. All right, so let's see. Where else are we going? So now we need to find the, that's the x-intercept. We need to find the y-intercept, and we know the same thing. Wherever it goes through, if it goes like, it's going to go through here, but wherever it goes through on the y-axis, we know it's x is 0. It's not over this way, it's not over this way, so its x value is 0, and it's some distance up or down. This would be, I don't know, negative 2.5, right? So we know the x value here has got to be 0, so we're going to do the same thing we did up here before. We're just going to plug it in a different spot. So instead of plugging it in here, we're going to plug in 0 for x, and this 3 times 0 is 0, and so now we've got just dividing by negative 4, right, to solve. So divide by negative 4, divide by negative 4, and y should be negative 3. So this comes in here at negative 3, like that. So your other point is at negative 3. So there's one point, there's the other point, and you draw your nice line, and you're done. Ka-ching, we just sketched it. Yay. All right, so moving on to the next piece. This is the same thing. We're going to do this a little more efficiently, right? I know where this hits this point. The x is 0, so put 0 in for x. 3 times 0 is 0. Divide by negative 5, divide by negative 5. Y should be negative 2, right? So there's our point. Ping. Do the same thing for this, right? Wherever this is, x is something, but y is 0. It's not up or down. So plug in 0 for y. This becomes 0, and then you divide by 3. So x is 10 over 3, right? 10 thirds is really 9 thirds and 1 more third, which is 3 1/3. So if you're graphing this, it's 3 1/3 of the way to 4, and we drew our line. Great, done. Ka-ching! Moving on. All right, we want to graph this piece too. If we graph this, we're looking at the y-intercept, right? So that's an easy place to start, is right there. And then we use the slope, which is rise and run. So you could think about this as rise over run. The rise is -1, the run is 5. You could make it the negative down here in the top positive, and it wouldn't really matter, but that's a deeper discussion. So let's rise -1 and run 1, 2, 3, 4, 5. That means that's your next point, right? So there's your line if you hit both of them, and it's done. This is the same sort of thing. Let's go blue, right? Here's our y-intercept. It's the y-intercept because if I know wherever it is on the y-intercept, it's 0, comma, whatever the y value is, right? So we put in 0 for x, and this goes away, right? And you're just left with the last piece. So instead of doing that every time, you can just see the pattern and look at the y-intercept value. Great, so we got the y-intercept value, it's right there, and we plotted it. So now we can take the slope and say this is the rise over the run. So it rises 1, 2, 3, 4. It runs 1, 2, 3. There's our next dot. Line done. All right. Next. Find the slope. Find the slope of the line. This one's a little tricky because if you graphed this, I hope you don't have to graph all of them, but it never hurts. 13, negative 1 is way out here at 13 and negative 1. And this one is negative 19, even farther out, and negative 1. They both have the same y values, right? So if you graph this line, it's horizontal. And horizontal lines have a slope of 0, right? Slope is 0. You can also think about it like this. Slope is rise over run, and this thing from this point to this point rises 0, and it runs, I don't know, 32, right? And you take 0 pizzas, divide them in 32 piles, ask your calculator, and it will confirm to you it's 0. That's fine. So we found the slope. That's all it asked of us. This is similar but a little bit trickier, right? If you take this point, this is negative 10, negative 10, and 9, 9, and this is negative 10, same spot, and negative 12, negative 12, right? And if you connect them with a beautiful line, and you look at slope is rise over run. How much does it rise from here to here? Well, I don't know, what, 21? And how much does it run from here to here? Well, none. It doesn't go over at all, so 0. If you ask your calculator this, it will explode, or it says error. And that's because we can't take 21 things and put them nowhere. This doesn't make physical sense, right? So this has undefined slope, right? You can think of it sort of as a walking path. If you think about that as a walking path and you're walking along it, that is the difficulty is 0 because it's just a path, and as the path goes up, the difficulty gets more and more and more, right? Until it's a wall, and then, right, it's no longer a path and you can't walk up it. So this has, you could sort of think about it as infinite slope, right? Or a really big number slope. But because it really is, as it doesn't run at all, it has 0 run, so this becomes some number like 21 over 0. This has undefined slope. It's no longer a walking path, it's a wall. We can't talk about it in the same way. Cool? Unless you have maybe a climbing rope like that. All right. So we're looking at 7. We're writing the equation for the line. This is really similar because if you pick 2 points on the line, any 2 points will do, you can find this rise over run of that as well. And this guy will have, let's see, this guy will have from here, I don't know, pick 2 points. That point, this is 3, 0. And this point is 3, 3. Yeah, this has some rise, right? This has some rise. The slope is rise over run. Rise is 3 units, but the run is 0, right? So this has undefined slope too. But that doesn't mean we can't find an equation for the line. We can still find an equation, and it would look like this. If you looked at all these points, let's keep our 3, 0. Here's 3, 3. Here's 3, 0. This is 3, negative 4. This is 3, comma, negative 1,000,000. They all have the same piece in common, and that's this value, which is the x value, right? They all have the x the same. And so in here, it doesn't matter how high up or down low you go, the x is always 3, and that's the equation of a vertical line. So the equation of this line that's vertical is x equals negative 2, because all these points have x values of negative 2, right? Negative 2, comma 4, negative 2, comma, negative 3, right? The x values are all the same. So there's our equation. Similarly, but with a twist, this, if we were trying to make the slope-intercept equation of this guy, we know we're looking for y equals mx plus c. Here's the slope, right? The slope is pick any 2 points and talk about rise and run. Well, rise is 0, so the slope is 0 over run is 1, 2, 3, 4, 5. 0 divided by 5 is 0. Bing. So this would look like y equals 0x plus c. And this intercept here, the y-intercept, is where the line crosses the y-axis, which is right here. Bing. So at -4. So this equation would look like y equals 0x minus 4. And since whatever we put in there for x, 0 times that is going to be 0. So we end up with y equals -4 as an equation. Another way to do that is look at the names of these points. This is 4, comma, -4. This is 0, comma, -4. This is -3, comma, -4. This is -1,000,000, comma, -4. All right, it doesn't matter how far left or right you go. The y variable, the y coordinate, the y value, y is always -4, which makes sense because the equation is y equals -4. That's why it's that. Great. Ping. So there's our solution. All right. So moving on to 9. Write the slope-intercept equation, ping, for the equation for this. All right, slope-intercept looks like y equals mx plus c, which means we need to move the x to the other side and then get rid of that -3. So if we do that carefully, this is a positive x, so let's subtract x from both sides. X minus blah minus x, these cancel out. You're just left with the -3, y, and on this side, -9 minus x. And that's great, and let's divide by -3, and then you have to divide each piece by -3. -3 times y divided by -3, those cancel, and you're left with y. -9 divided by -3 is +3. This negative and negative is going to be a positive, and this is going to be x over 3. If we turn that around, it'll look like x over 3 plus 3. This is positive, right, so it's positive up here. This is positive, so it's positive right there. Great. So this is the equation. Now, I don't love it because I can't see slope. Like, I want to see a number in front of the x, and I just see a number below the x. So I'm going to think about this as y equals, instead of x divided by 3, think about it as a third x plus 3. Dividing by 3 is the same thing as multiplying by a third. It's sort of like saying 6 divided by 2, yeah, that's 3. And 6 times a half, yeah, that's 3. It's just a different way to show it. And we like it this way because it has slope sitting there. Ting. So I like this equation, and I'm going with it. So let's move on to 10. Same sort of idea. In 10, change it to slope-intercept form. Well, then this should be, let's subtract 9x and subtract 9x. These cancel out, and you're left with 4y equals 32 minus 9x, and then let's divide by 4. But you got to divide everything by 4. And these cancel out, you're left with y. This is what, 8, and minus 9/4 x. Let's spin it around. So this is negative, let's keep it negative. Negative 9/4 x. This is positive, so let's keep it positive. Cool. With this slope, it really doesn't matter if you call it -9/4 or 9/-4 or -9/4. I like writing it like this best, but thinking about it like this best. I think it looks crisp if it's -9/4 x plus 8. But it's easiest for me to think about -9/4 when I'm graphing, right? This, if we graphed it, this would be plus 8, start at 8, and then it rises -9 and runs 4, boom. And there's your line, if you hit that point, actually. All right, moving on. You didn't need to graph that, BT dubs. All right, so with this last part, right, we want to write it in standard form. Standard form looks like whole number x plus whole number y equals whole number. X's and y's on the same side, so let's move that to the opposite side by adding 3/5 x to this side and adding 3/5 x to that side. So the left side looks like y equals 3/5, y plus 3/5 x equals this and this have canceled, and you're just left with the 3. That's lovely, except this ridiculous denominator. So let's multiply both sides by that denominator. This becomes 5. This becomes, I'm just going to write it out, 5 times 3/5 fifths x, and this side becomes 15. If you're not sure about this piece, this would look like, if you're multiplying, this is 5 over 1 times 3 over 5 times x, right? 5 times 3 fifths times x. That's what this is. So to do this, let's just think about this piece. If you multiply everything on top, that's 15. You multiply everything on bottom, that's 5. And that simplifies to 3. And x is still sitting there waiting. So this turns into 3x. And that's why we did this, to get rid of this ridiculous denominator. You can also do this by just simplifying. Hey, look, I've got two fractions being multiplied. Top and bottom has something equal, so let's cancel them out, because 5 divided by 5 is 1. So cancel them out, and you're just left with 3 over 1, which is 3. So long story short, we did all that, so these cancel out, and you're left with, oh, I forgot my y there. Why didn't you tell me I forgot my y there? Come on, man. We're left with 5y plus 3x equals 15, and we're done. Standard form. Yay. All right. Hey, who wrote all over this? I guess it was me. Same thing. We got to move that 7/2 out of there. And to do that, it's positive. So to do that, we have to subtract the 7/2. 7/2 x from this side minus 7/2 x from that side. This should be y minus 7/2 x. These have canceled out. That's why we did all that work. And now let's multiply by this denominator. But you got to multiply everything by it. So this becomes 2y. This becomes minus 2 times 7/2 x and 8. Let's call this 2 times 7/2 x. 2 times 7 divided by 2. These pieces cancel, and you're just left with 7x and 8. Whole number, whole number, whole number. Integers. We should say integers. Ching, done. All right. Let's see what else we got. What else we got? Oh, nothing. Nothing on that page, huh? All right. All right, last page. Here we go. So slope-intercept form. Okay, fine. Slope-intercept form looks like y equals mx plus c. This one's nice because if we thought about it, this is -4, -1, and this is 0, -4. So this 0, -4, that's the y-intercept, right? So we know what c should be. This should be c. So all we really need to do is find slope, and slope is the rise over run, right? Rise over run. The rise is the difference between the y values. So to go from -1 down to -4, that's a rise of -3, right? To go from here down to here, this is at -1, this is at -4, you have to go down 3. The run is from -4 up to 0. It's from -4 going positive direction up to 0, so that's an increase of 4. So the slope here should be -3/4. Cool. So our equation can look like y equals slope x plus c, and we're done. Now, if you didn't see that this value gave you this, you'd run it a different way, right? And this will bring us into what 14's asking of us. So let's try it without knowing that, pretending we hadn't seen that this is the y-intercept, just to show you that we'll get the same answer. So I'm going to leave this here, but we're going to try to target it in a different way. All right, so I know that our slope is going to be -3/4. This is going to look like y equals -3/4 x plus c. We can figure that out and change in y and change in x, right? That's not a big deal. Man, if we know that this is an x-coordinate, and this is a y-coordinate, and this is an x-coordinate, and this is the y-coordinate, we can find an infinite number of these by picking some new x value, like 8, and plugging it in here for x, and cleaning it up and getting a y value if we only knew what c was. However, there are two of them that we do know. One's here and one's here, right? So I'm going to pick the ugliest one and show you that this is, I'm going to pick this one, and show you that if we put in that value for x, we should expect to get this value out for y. And if we substitute those in, say, hey, I expect to get out -1 if I put into my equation this x value, even if I don't know c, I know that this point or that point or any other point that they give us comes from this equation. So plug in what we do know, and then we can solve for what we don't. If you clean this up, the negative and the negative should be positive, so like these pieces will cancel out and be positive, and this is 3 times 4 divided by 4, those cancel out. So you're just left with 3, -1, plus c. Let's subtract a 3, subtract a 3, these cancel out, and you're left with c is -4, right? -1 minus 3 is -4, which is just what we thought, right? We're going to play that same game over here. So we're going to first find the slope. The slope is rise, so to go from 2 to -3, that's a rise of -5, goes downhill. And so slope is rise over run is -5, and going from 5 to -5, that's a decrease in 10, so our slope should be 1/2. Cool. So great, now we can say y equals 1/2 x plus c. I don't know c, but I have an x value and a y value that I could choose, and actually I have 2 of them. Which should you pick? You should pick the least ugly one, right? So I'm going to, in place of this x, put our x value, and in place of this y, put our y value. There we go. Put our y value. Sorry, having technical difficulties. So I should expect to get 2 out if into the equation I put 5. All right, this 5, this 2. This is being multiplied, this is being added. So 5 times 1/2 is really 5/2, and c. And then to get rid of 5/2, we'd subtract. So -5/2, -5/2. This will be 2 minus 5/2. These cancel out, is c. All right, we've got to turn this into halves. So 2/2 is really 2 is really 4/2. 4 divided by 2 is this 2. We did that, so now we can have common denominators. And we can solve from there and say, well, 4/2 minus 5/2 is -1/2, which is c. So now I have slope and I have intercept. Actually, that was vice versa. So you can say y equals +1/2 x minus, well, plus c. Whew, done. All right. Find the distance. All right, distance is Pythagorean theorem. We know with the triangles like that a squared plus b squared should be c squared. And they're actually talking about the sides of the squares, the areas, but we're going to use those instead of talking about the areas. We're going to just talk about the lengths using the square roots. So this distance is 1, 2, 3. So this is 3, 1, 2, 3, 4, 5. This is 5. So this length, c squared, is 3 squared plus 5 squared. That's 9 plus 25. That's what, 34. So c squared is 34. So c is the square root of 34. This can't be simplified, so you got to leave it. You could decimal it, that's fine too, but this is clean. Let's try this one. All right, this distance is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. This is 3. So c squared should be 9 squared plus 3 squared. So what, this is 80, 81 and 9. So this is 90. Great. So c should be root 90. For now, that's great. If you take the root of it, you get 9.486 blah, blah, blah. If you want to learn how to clean it up, what you can do is think about this as 9 times 10, right? That's 90. And then you can take the square root of each piece. It's mathematically legal, and that's nice because square root of 9 is 3. Square root of 10, we could do it again by doing 5 and 2, but neither of these pieces are perfect squares. They're not nice squares, so they can't really be simplified. So this is 3 root 10, and if you plug that into your calculator, 3 root 10, you still get 9.486 blah, blah, blah. This is the same thing. So this is great, this is great, this is amazing. Yay, right, confetti, great. Da, da, da. All right, this part, they're asking us for the distance. It's the same thing. Instead of graphing it, look at the distance from -8 to 4, right? That's 12 units. And the distance from 6 to -3, that's a distance of 9 units. So c squared is just going to be 12 squared plus 9 squared. 12 squared plus 9 squared is 225. And I think that when you take the square root of both sides, I think that's 15, right? Yeah. Ping. All right. This last one, I don't think will be as pretty, but this is a -1, right? And this from 2 to 8 is 6. So this is -1 squared plus 6 squared equals c squared. Be careful when you do this piece. In your calculator, you have to put these brackets in, or your calculator won't, it'll give you -1 instead of +1. This turns into 1 plus 36. So 37 is c squared, so c is root 37. And I don't think it gets any cleaner. Just leave it like that, or decimal it, that's fine. All right, find the midpoint. Well, the midpoint is the average of the two values, but you could think about this as 4, 1, 2, 3, 4, and -9, and 4 and -5, right? So we're trying to find the halfway point between those two. And these, the average of these is going to be still 4. So you go 4 plus 4 over 2 equals 8 over 2 equals 4. No, not surprising. And that's for the x value. And then for the y value, you do the same thing. Let's do it in a different color. So for the y value, you say, all right, well, I got a -9 and I've got a -5. So on average, how negative is it? Well, this is divided by 2. This would be -14 over 2, so -7. Yeah, just -7. Great. And so this point will be 4, which makes sense, and -7, which also makes sense if this is -5 and this is -9, halfway between them, -7. On average, they're -7 up or down. All right. Bum, bum, bum. So, okay, here's 20. We got to do the same thing. This change, we're talking about distance, so I'm going to write a triangle. This is down 4. This is -9. This is +4, -9 up to 4. So this is going to be c squared is going to be -4 squared plus 4 squared. So this is 16 and 16. So this is c squared is c is 32. So c is root 32, which is a funky decimal. It's 5.656 blah blah blah. So this is good, this is good. If you're a true math hero, you simplify root 32 like this. You say 32 is 16 and 2. This is a perfect square, so if you take the square root of each piece, root 16 is 4, and root 2 is root 2, and this is the same funky decimal as this if you put it in your calculator, but leave this as a clean radical. I'm happy with either of these two, though. All right, bum, 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 and we got 2 more. So now we're getting funky fractions, which isn't great, but we can do the same thing. We're just trying to find the midpoint. So the change between, we're saying we're taking the average between here and here. We're adding them up and dividing by 2, right? And that's our average x. Oh, shoot! I think I found the midpoint. I found the distance for that. Oh. Sorry, found the distance for this guy. Backing up. If you find the why didn't you guys tell me? If you find the distance between sorry, the midpoint between this, it's just the average of those two divided by 2. So that's 0 over 2, so that's 0, which makes sense because one is at positive 2 and the other is at negative 2, so halfway between the two is 0. And the average between these is negative 9 plus negative 5 over 2, which is what, negative 14 over 2, which is negative 7. So I think that's our midpoint. Cool. The solutions are on the back. Check that I'm doing them right, because sometimes I'm off, just like missing that. So here's our x value. We're playing with fractions, so this has to turn into fractions. So this is negative 18 ninths. That's 2, right? Plus 2 more ninths, all over 2. This top numerator ends up being negative 16 ninths, all over 2. And if you divide fractions, you can think about this like this. This is divided by 2, this is divided by 2, right? And if you divide fractions, I'm going to think about 2 like that. And really, when you divide fractions, you flip this second piece and you multiply. So let's multiply by 1 over 2, which is nice because this becomes 4, negative 16 over 4, and negative 16 over 4 is just negative 4. So the average x is negative 4. We can do the same thing with the y value. Going from, oh, sorry, that's the y value. Why didn't you guys tell me? This is y average. The x average is going to be 3 tenths plus negative 1 tenth all over 2. This is the x this time. So this is 2 tenths over 2. So this is 2 tenths divided by 2 over 1, which is 2 tenths times 1 over 2. These cancel out and you're left with 1 tenth. So that's our x average is 1 tenth. So I think it would be 1 tenth comma negative 4, something like that. All right. Last but certainly not least, midpoint for this. Let's find it for x first. Here's x hat is 3 halves plus 2 and 5/6, negative 2 and 5/6 divided by 2. 3 halves, let's see, this would be minus 2 and 5/6. 2 is 12 sixths and 5/6, right? 12, so this is 13, 14, 15, 17, 17 sixths all over 2. We have to turn both of these into 6, so I'm going to multiply this piece top and bottom by 3. This becomes 9 sixths minus 17 sixths all over 2. And this becomes negative 8 over 6 divided by 2, which is negative 8 sixths divided by 2 over 1, which is negative 8 sixths times 1/2. And this can cancel, left with 4. So this is negative 4 sixths, which is negative 2 thirds. Great. We're going to do the same thing with the y values, but it'll be a little bit easier. Average y is going to be 2 plus negative 5 and a half over 2. This is 2 minus 5. 5 is 10 halves and 1 more half, so 11 halves all over 2. 2 in halves is really 4 halves minus 11 halves all over 2. So this is negative 7 halves divided by 2, which is negative 7 halves divided by 2 over 1, which is negative 7 halves times 1 over 2, which is negative 7 fourths, right? Multiply everything on top, everything on bottom. So I think that's y hat, negative 7 fourths. So I think our average, our median values are negative 2 thirds and negative 7 fourths. And I think it's the midpoint. Holy wow. Cool. 1/10 and negative 8/9. Let's look where that is. All right, somewhere in here. I missed this piece. That's why you check your answers. 2/9. All right. So -2, 18, 17, 16. That's all right. I'll find it and come back to you. Found it. All right. This somehow went from ninths to halves. I don't know why. So this should be halves, halves. So this should be halves here and, sorry, ninths. I did it again. Ninths and ninths and ninths. And then the 2 and the 16 cancel, and you get 8. So you get negative 8/9. So negative 8/9. So negative 8/9. Cool. All right, let's go from there. 7/4, yeah. 4, yeah, right. This is negative 1 3/4 is -1, negative 1 plus 3/4, right? 1 is 4/4, and 3/4 is 7/4, right? The negative outside. Cool. All right. Ooh, looks like I messed up something on this one. Sorry about that. 1/10 and negative 8.